Hi Algebra 2 students. This is the video for section 8.3, which is going to continue along with our graphing material following section 8.2. So if you are not taking the retake, this is what you're going to be doing in class. If you are taking the retake, you want to start watching these videos after you finish your quiz and then finish up whatever is needed for homework. So we're going to get started with a warm-up. That's just going to review what we covered in class yesterday. So graphing our basic rational functions. So this problem number 1, you have a graph that you want to get sketched on your axes. This y equals 3 over x minus 2 plus 5. So first up, you want to find your vertical asymptote. So remember, an asymptote is a line that our graph will approach, but will never actually touch for these rational functions. So my vertical asymptote happens where I try to divide by 0 in the denominator. So I want to take x minus 2 and set it equal to 0, which means that x equals 2 is going to be my vertical asymptote. So if I grab my ruler, I want to sketch a dashed line right at 2 to show that I will have pieces of my graph on either side, but no points actually at 2. Then I want to find my horizontal asymptote. So my horizontal asymptote is going to be the line that goes side to side that my graph will approach but not touch. Now when I have it in this format, where I have a constant divided by x plus or minus some number, and then I have plus another constant here on the right, this value, this constant, is going to be my horizontal asymptote. So that will be y equals 5. And remember, the reason that we get that horizontal asymptote is that 3 over x minus 2 expression, so this guy right here, is never going to be equal to 0. So if that term can't be 0, then there's no way I can get 5 out of the expression. So now I want to flip my ruler, or my straight edge, at 5, and I'm going to sketch my horizontal line here. So I'm shifting my graph center from 0, 0, now to 2 and 5. So what I like to do is to pick 2 points above my vertical asymptote of 2 and 2 points below. So for me, that might be 0, 1, 3, and 4. But I could pick further to the right and further to the left if I wanted as well. So now I want to go ahead and plug those values in to my function. So when I plug 0 in, I'll have 3 over negative 2 plus 5, which is going to give me negative 1.5 plus 5, or 3.5. So that's going to be this y value. Then I'm just going to erase and keep writing up here as I plug in my values. But if you want to do them on the side, you certainly can. If I plug in 1 for x, I'll end up with 1 minus 2, which is negative 1, plus 5. So this is going to be negative 3 plus 5, which will be positive 2. So if I go to plot these points, 0, 3.5 is going to be right about here. And then 1, 2 will be right here. So this rational function branch is going to come kind of down here like this. That's my left-hand piece of the hyperbola. Then I want to plug in the 3 and the 4 as well. So if I plug in 3 minus 2 here will give me a 1 plus 5. So I'll end up with 3 plus 5, which is 8. So I have the point 3, 8. So over 3, up 8 is a point right here. And then one more x value to plug in, which is 4. Now if I plug 4 in here, I will get a 2 plus 5, which is going to give me 1.5 plus 5, or 6.5. So I've got the point 4 and then 6.5, which is right about here. So I can then sketch this piece of the hyperbola here. So that's my graph. My center has shifted from 0, 0 to 2, 5, and then my graph has been vertically stretched. So let's just analyze what we can about this graph. If we want to compare it to our parent function, here are the things that have changed. We have translated to the right by 2. we have shifted up, so we've translated vertically up by 5. And then that 3 has stretched out our graph vertically relative to the parent function. So those are the 3 things that have changed. Then we want to go ahead and take a look at problem 2. So problem 1 was in our format that allows us to really easily identify shifts to the left and right and up and down. Problem number 2 is a little bit different because we just have one linear function divided by another linear function. So it's not in the format that we can as readily see where our shifts have occurred. So what I want you to do with these ones is still begin by identifying your vertical asymptote. And that still happens by taking a look at the denominator and setting it equal to 0. So x plus 2 equals 0, which means that my vertical asymptote occurs when x is equal to -2. So you want to find -2 and then just graph your vertical line right in there. Then you want to find your horizontal asymptote. So the process of finding your horizontal asymptote is just a little bit different here. Instead of looking for the constant at the end, what you just want to do is to compare your values in front of the x. So up top here I have an 8, and down below that guy is technically a 1x. So if I divide those values, 8 over 1, my horizontal asymptote will happen where y is equal to 8. So if I flip this to be a horizontal line instead of a vertical line, I'm going to have a sketch right across here, and that represents the flat line that I can't cross there. So I still have a shifted center, but the shift just wasn't quite as clear from the equation itself. So that's my vertical asymptote, that's my horizontal asymptote. And then I still want to pick points to the left and right of this -2. So let's pick -4 and -3. And then on the right-hand side, let's pick -1 and 0. So we want to plug each of those into the function and see what we get out as our values. So if I plug -4 in, I'll have 8 times -4 minus 8 over -4 plus 2. So 8 times -4 is going to be -32 minus 8 more will be -40. And then -4 plus 2 will be -2. So my y output here is going to be 20. So that value is going to be really far off of my chart. I'll be -4, 20 is going to be somewhere sort of up there. Then if I think about my -3, why don't I come down here to plug that in? 8 times -3 minus 8 over -3 plus 2. 8 times -3 is going to give me -24 minus 8 more over, this is going to be -1. So I will have -32 over -1, or 32 as my y output there. And so that point is also way off of my chart. So I'm at -3, and then 32 is way up here. So this is really tricky to see what my graph's going to look like well, because it comes so far up above the graph, but it's going to be something like this rounded piece up here. You'd want to sketch this out with your graphing calculator too. Now that's a little bit too many lines to try to shade that in. But it's essentially going to go like this is what my shape looks like. Then let's plug in -1 and 0. So I'm just going to erase my previous plug-in work so that way I can really clearly see just what specific value I am plugging in. So I want to plug in -1. So I'll have 8 times -1 minus 8 over -1 plus 2. So this is going to give me -8 minus 8 more over, this is going to be a +1. So this will be -16. So still not quite really well on my chart. So -1, -16 is going to be down here. And then if I plug in 0, I will have 8 times 0 minus 8 over 0 plus 2. So this is going to give me -8 over 2, which is -4 as my final y value. So 0, -4 is right about here. And so I'll find that this rational function if I'm just kind of sketching the general shape and not plotting perfect points, will look like that. So I apologize that that one goes so far off of your chart, but you can see that general sketch there. Now that's our 8.2 material. Today we're getting into 8.3, where we're going to graph rational functions that just have a little bit more going on up top and down below. So we want to take a look at the equation here, y equals 2 over x squared plus 1. And just like before, I want your first step to be to consider where your vertical asymptote occurs. So remember that you have a vertical asymptote anytime you try to divide by 0. So you always want to take your denominator, or the bottom part of your fraction, and set that to 0. So in this case, I'll take x squared plus 1 and set it equal to 0. But then if I try to solve for my x values, at this point, I'm going to end up with imaginary numbers, plus or minus 1i. So I only would have vertical asymptotes where imaginary numbers happen, so I don't have any on the real number plane. So none that I have to worry about here. Then when it comes to my horizontal asymptote, what I really need to think about here is how the exponents in the numerator, so the top part of the fraction, compare to the exponents in the denominator, or the bottom part of the fraction. So notice this 2 is really the same thing as saying 2x to the 0 power, because that's really the same thing as 1. So my exponents up top are smaller than down below, so larger exponents in the denominator than what I have in the numerator. So anytime that's the case, when we have these larger values down in the denominator, we're just going to have a horizontal asymptote at y equals 0. So that's just a rule that we want to recognize. Larger exponents down below mean that I'm going to just have a flat line at the x-axis. That will be my horizontal asymptote. Nothing to worry about as far as my vertical asymptote. So what that means is I just need to pick some negative numbers to plug in and some positive numbers. So let's plug in -2, -1, 0, and let's do 1 and 2 as well. So if I plug -2 in, this value, -2 squared, will become a 4. 4 plus 1, this is going to be 2/5. If I plug -1 in, this will become a 1 plus 1, so 2 over 2. This is going to be a 1. If I plug 0 in, this will become 2 over 0 plus 1, or 2 over 1, which is 2. And then I'll have the same operations for 1 and 2 that I had for -1 and -2. So 1 squared will be a 1 plus 2, so this is going to be a 1. And when I plug 2 in here, this will become a 4 plus 1, so this will be 2/5. So I've got enough information to sketch the graph shape here. So -2, 2/5 is going to be a decimal here. -1, 1 will be right here. 0, 2 is here. And then 1, 1 is here. And 2 and 2/5 is going to be here. So this graph is never going to touch 0, so we're going to have this kind of shape here. So it almost looks like an upside down parabola in the center, but it's not quite. And then it's going to continue on each side, just getting smaller and smaller and smaller and smaller, but never actually touching 0. So this is an example of where my exponents are larger down below in the denominator than they are up top in the numerator. So we can say exponents in the denominator are greater than the exponents in the numerator. And anytime you have that occur, you will have a horizontal asymptote at y equals 0. So we're going to take a look at a few more cases. So check out the next video for your examples 2 and 3.